AP brain dump. What do we do before we start the exam to make our booklet much more user-friendly? Obviously, you would do this with a pencil, so think of it like this. So like if I'm highlighting, so I take my pencil or my pen, I'm going to draw down here, I'm going to draw around here and make the magic B. Those represent the ions that come from strong bases, so anything with an OH in there is going to be a strong base. I'm going to go Cl, Br, and I right there. Those are from strong acids, and I add two more. I add NO3 minus and ClO4. And those represent all my heartbreaker ions. So that's the first thing you do. Mark the heartbreaker ions. Across the top of your periodic table, you can write the number of protons increases, the effective nuclear charge goes up, radius goes down, ionization energy would be up. Because the closer the electron is, the harder it is to remove. So if you go and take a look there, that explains the trend in ionization energy and size within a period. So that's like comparing like phosphorus and sulfur. Start with the proton number, and then you start left to right, and then you just answer it. You brain dump that on your test. Then we're going to go to the thermodynamics section. The first one up here is Q is equal to MCAT. Now, if they ask you for heat of a reaction and they mention a coffee cup in the problem, so they're doing a reaction in a coffee cup, that's when you don't use Q is equal to MCAT. You add the negative MCAT, and then you divide by the moles of whatever they're reacting, the smallest number of moles. It's basically, so it's negative MCAT divided by moles. Next thing, we're going to come over to the Gibbs free energy equation. Delta G is equal to negative delta H minus T delta S. Remember, the key thing here is you have to divide by 1,000. S has to be in kilojoules in order to properly calculate out delta G. The reaction below it is a Ratlink equation. Remember, we say delta G is equal to negative RT, natural log of KQ. This one, delta G has to be in joules. So write 1,000 there. The 1,000 will remind you that you have to multiply delta G by 1,000. It has to be in joules. Got it? You have the negative in NFE for the delta G value if you have an E cell problem. Drop all the way down below, and what we're going to do is we're going to do our delta H, delta S table that you should have memorized by now. So it goes like this. Minus plus is always spontaneous. Plus minus is never spontaneous. And then we get to the signs when they're the same because temp matters. Plus plus, high temps, you'd have a negative delta G. High or hot, we'll say high, not hot. And then minus minus would be low temps, and there you go right there. The only other thing you could add is you could add over here, you could say delta H over delta S also equals the temperature at which a reaction becomes spontaneous. Or if they say, hey, when is KEQ 1? What temperature? It means H over S. Just make sure S is in kilojoules. The last thing you would add is over here, I would add it NFE just in case they ask you for electrolysis question. Now, if you think about like here, if you look right here, this is the number of electrons in the reduction of the metal ion. So like if I have like Au 2 plus, gold 2 plus, well, I would have to add 2 electrons to make that a solid, Au, and that's what the E is. That doesn't represent E cell, that's why it's a cursive E. So it NFE for the electrolysis, and we solve for N. If you brain dump this right the first 5 minutes of the test, you're ready to go. You have every piece of information that's going to be helpful within the calculations or conceptual questions that require a lot of memorization. All right, get ready, rock that test.